we go. All right.
Thank you for having me. I don't know how many of you have interacted with GIS applications or know anything about it. So if you haven't, maybe this talk will help with that. So before I start, one thing I can say is I'm not really a master in GIS applications. I can't say like I'm a full GIS application developer. So maybe I'll have, but I believe I have like enough context into the topic. So if someone has maybe better insights, it's good you can share on the chat as well. And so I haven't done any GIS application in production, though back in the day I played around with it, especially the web GIS. Now with the caution out of the way, so why should you listen to me? Why should you listen to this webinar? So there are a number of reasons why I believe you should just listen to me, in as much as I haven't done any production application using GIS. So first of all is my background. I did urban and regional planning with IT, and currently I'm doing a master's in planning. And if you're familiar with planning, maps are our bread and butter. So anytime you want to do, let's say you do a plan, you need sometimes to just get this information out to the people, and there's no better way to do that than to show it in maps. So sometimes you want to see how, let's say, currently I think the key topic you've had is the issue with the environmental conservation, where we are losing forests. And I think over the years we've started to see a rebound in the forest cover of the country. So the only way we'll do that is through mapping, is where we'll be able to determine whether that is the case or not. Other than that, in as much as I've done planning, I haven't really practiced planning. So I think most of my professional life has been spent in software. I've worked with Ruby on Rails for a while, starting back in 2012. So I actually did a similar talk where I just tried to integrate GIS with Ruby on Rails. So I think it's somewhere online. So over the years, I think for the past few years, I've been playing around with the Elixir, not necessarily professionally, but as a side project, something you just do on the side over the weekends at night. Yeah. And I've come to like love it because as you know, like software developers, they normally play around with a lot of technologies, but to me, Elixir is kind of stuck. It's something that has been consistent in my life alongside Ruby on Rails. So, and lastly, I'm planning to like do a real production application using GIS. So it won't be like a full GIS application, but it will be really GIS heavy, where we'll have a lot of maps, among other things. Yeah, so I think with that out of the way, I hope that will convince you to stick around for the talk. So one thing we need to understand is what is GIS. So GIS is mainly a spatial system which creates, manages, and analyzes maps of all types. So GIS is not really like one thing. It's actually made up of different layers. So for example, every map you'll see, especially those maps which are thematic, something like, I'm sure you've seen maps which shows the roads. So for instance, if you just look at Google Map is something like GIS. You have something like roads. You also have buildings. So these ones are called something called layers within that map. So you're able to overlay these. And despite it's looking just like an image, you can actually develop better maps which shows different characteristics of an area. Let's say you want to determine the type of people who live in a certain area in terms of their income, among other things. So you can actually overlay different layers and see that in GIS. So through a GIS system, actually, it just creates, manages, and analyzes maps of all types. And the most important thing in GIS is the collection of the data and analysis. Display is actually not really important. It's actually like a small fraction of what is required in GIS. So most people in GIS will actually spend most of their time just collecting the data, cleaning it, to be able to get it to work in these applications. So through GIS, you're able to connect data to a map, integrating location. So you'll be able to know where things are in a given space, in space and time. So you'll also know how things are in a certain area. And this is really important when it comes to decision making for not just businesses, governments, and also currently, I think many applications are actually moving towards integrating the location aspect into their day-to-day processes, because there's much data which, in as much as people can actually misuse the data, but if you use it wisely, you're able to not just help provide people with better services, but also just gain that comparative advantage. So through GIS, we are able to do like mapping and analysis, which is used like across a lot of industries. If you just Google like the application of GIS, you'll find it's used not only in planning, it's used in business, in war. They actually use GIS applications. So why GIS? So GIS allows us to understand patterns, relationship, especially within the geographic context. Let's say we want to know about the weather pattern in a given area over time. Through GIS, we'll be able to do that. So through these benefits, we are able to, just make better decisions, especially when it comes to managing of resources. One thing with planning is about managing scarce resources. We try to help people to like protect them from themselves. Because if you leave people to do the way they want, you'll have a situation where, can you hear me?
Yep, we can.
Okay. So people, if you leave them to live the way they are, they'll actually do crazy things. So that's why we need to, it just allows us to make better decisions, not just for ourselves, but for the future generations as well. So one thing with the GIS is the data types it uses is slightly different. And I remember I read somewhere recently that like if you're a web developer, you're actually 50% a GIS developer. So you just need to learn about 50%, which I believe this talk will guide you on what you need. So if you look at most geospatial systems, they operate using a given standard which defines the different data types that you can use. So this standard is called Simple Feature Access Specification, and it's maintained by Open Geospatial Consortium. You can actually check them out online. So they just help with the standardization of different GIS applications, the same case as I think ECMAScript does for TypeScript, and different standardization organization does for different languages. So if you look at GIS, we have like, alongside the data types, I'm sure if you've worked with any database, you're familiar with text, strings, integers. So GIS has like 7 more concrete data types. So these data types are able to represent points and linear objects within a 2-dimensional space. So in addition to, we have like different standards, things like operations you can carry on the data that you have. So the main data types are divided into two main areas. We have like geometric and collection. So the 7 data types are divided into 3 geometric and 4 collection, which we'll look at next. So the geometric data types, we have something like points. So this one are used to show like points of interest. Let's say you want to show a school within a map, a hospital. When you look at Google Maps, you normally see those addresses showing a place. And so let's say when you want even to go to a place, you normally look for the name, then it will show you with a marker. So that is typically what a point is. So this is just a simple 2D, a simple point in the 2D space, and it mainly consists of X and Y coordinates, which are longitudes and latitudes. We also have a line string. So this is used to show something like roads, rivers. Then we have a polygon, which is a contiguous area in a plane, in a 2D plane. So this one is used to show something like boundaries, city boundaries, what the boundaries, among other things. So here are just examples of this. So here we have a case where you have the vertices showing the points, vertices and the points. So these are just the primitive things that make up GIS data. So in as much as if you look at them individually, they don't really make sense, but once they come together, that's when you'll see much more sense in them. So here is an example of a polygon. So we also have collection types. So this one represents 0 or more geometric type. So it's just like adding on what the geometric type have. So for instance, we'll have multi-point, which is multiple points, multi-line string, the same case as multi-polygon. So something like the map of Kenya, map of Africa, is actually consists of different polygons that come together. So there are a number of operations which you can do on these types. So we have like a class hierarchy to do this. So for instance, you can do something like intersection between two different areas. You want to find whether an area is included within a certain area. So these are just some of the things which the GIS data types add on a GIS system. So something like you may need to find the size of an area, which is also another operation that you can do on these geometric data types. And these operations are done in such a way that are language agnostic. So if you follow the standards, you can implement it with any programming language that you're using. So another thing to consider in GIS is the raster versus vector. So this is like, if you look at GIS, especially the older proprietary applications, something like ArcGIS, QGIS, and other GIS-based application, you'll find the use of raster versus vector. So vector data is really simple. So it's made up of vector graphics comprising of vertices and paths. So these ones actually work together to create something like points, multi-polygons, and all that. So the 3 basic symbol types for vector data are points, lines, and polygons. So through this, you can actually create anything with the GIS. There's also the raster data. This is just made up of pixel. So for instance, you get if you take like a picture with a drone of an area, that picture, in as much as you may think you'll have a lot of insight into it, it won't really do much for you. You need to do something called georeferencing. So with georeferencing, we'll be able to put it in a GIS application, and it will be able to be shown to belong to a certain area in space. So raster models are useful for storing data which varies continuously, something like, let's say the size of an area, like how forested an area is, such kind of stuff. And it's especially done with pixels. There's the content such as images, which are, for example, you can have satellite taken images, drone imagery. So this one just comprises of raster. And as I mentioned, you need to georeference this to be able to make sense in GIS with that data. So another thing we'll talk about is coordinate systems. So there's this address. If one day you find yourself in Mars, I'd advise you go and visit this place. So this one is it's called Olympus Mons. This is like the highest mountain in the solar system. Yeah, it's about 25 kilometers high, and it's around the size of the state of Arizona. So right now we are in Earth, but we are able to determine the exact address of this place. This is because of the power of coordinate systems. So coordinate system is just a method of identifying location of a point. So this can be on Earth or even on any other planet. Because if you look at organizations such as NASA, they've actually mapped other planets. So we know the coordinates of, let's say, we know the location of a given system in Mars. When we send out those probes, we know where they are going through use of coordinate systems. So most coordinate systems use two numbers. So this one are used to identify a particular location of a point. So each of these numbers indicates the distance between the point and some fixed reference called the point of origin. So why should we? Why does coordinate system matters? So this is because you know, the Earth as it is, it's not flat. Yeah, in as much as there are people who believe that Earth is flat, but Earth is actually a spherical thing, shaped something like a ball. Yeah. So this one has impact in a lot of things. So something like aviation. If you look at the map of the Earth, most people may think that the shortest distance is a straight line between 2 points, but most likely that's never the case. It's actually, if you look at even how aviation works, most planes will actually go towards the northern hemisphere, then come down, in as much as they are going from points which are just in the same, like in the equator. So you'll find them going up, then down. So this is because due to the spherical nature of the Earth. So location applications generally work with coordinate systems related with the surface of the Earth. So we have like three main coordinate systems. We have geocentric coordinate system. So this one is a 3D coordinate system, and its origin is at the Earth's center. So the main basis of this is in the middle of the Earth. So this one is not really used that much. So, but sometimes it's convenient to do some other crazy computational geometry and analysis of different things. So this is an example of that geocentric. So I'm sure if you did geography, you remember the Greenwich meridian, the equator, among other things. So we also have a geographic coordinate system. So this is the most prevalent used, and it's mainly the latitude and longitude. So for any location on Earth, we have the latitude and longitude to show that. So it's used in identifying different points in terms of degrees, and there are actually hundreds of these geographic coordinate system. But the main one which you'll come across when you are doing any mapping or GIS application is WGS 84. So this one is what, like, if it's anything that you need to pick up is just this WGS 84. This is one thing that you'll use for a lot of applications. In as much as in other areas, some other coordinate systems are much suitable compared to this, but this one is the most predominant, yeah. So this is an example of that, where you see we have different locations. So we have like the Earth as a plane. We have the latitudes and longitudes, and through this we're able to determine the location of the Earth, the location of any point on Earth. Yeah. So there's also the projected coordinate system. So projection involves taking a portion of the Earth and flattening it. So as I said earlier, the Earth is spherical in shape, but we can't really make sense of that. We need to put this in paper, let's say on our phones. So through projected coordinate system, we are able to do that. So these coordinate systems are planar and generally Cartesian for easy display and computation. So anytime you see a map in paper or even in the phone, that's actually like a projected coordinate system. So there are different projections which are used up there. And I'm sure you've seen this map. Like this is the most common map of the world. In as much as there's a lot of criticism about this map where people feel it's really biased in how it shows things. So for instance, if you look at this map, you'll see Greenland is actually almost the same size as Africa, something like North America, Europe, Russia is really huge. But in reality, this is the actual map of these areas. So for instance, Greenland, this is just the actual size of Greenland. The United States can actually fit Africa 3 times. Russia is not that huge. So the reason for this is due to projection. So if you remember, which I shared earlier, the projected coordinate system, which allows us to change the Earth from spherical to something that you can put on paper. So this one comes with a lot of issues, such as this, where we distort the map. But the reason for this is geographically, it's okay in as much as it portrays, there's been like a lot of issues, especially due to this, where if you just read through, the Mercator projection, it's what is used here and used by Google Maps among many maps. So many people actually think that that is how the world is, how big Russia is, but in reality, that's not the case. So this is the actual size of these countries. So why Elixir? So the reason why we should go with Elixir is Elixir is performant. Just a minute. Sorry about that. My daughter think wants something to eat. So let me just continue. So one good thing with Elixir is performance. And GIS applications, in as much as they look simple, they're not that simple. Because you may have a situation where your application actually is getting data from even 100 data points. Think of a case where you have a department, let's say a security, let's just talk about maybe the national security of the country. So you need to have different data points. So in that case, you need a tool that is really performant, offering good reliability, especially when you want to do these large-scale GIS applications. So this complexity makes Elixir a good tool for it, considering that Elixir is built on top of battle tested and been used to do a lot of things. There's also the aspect of the tooling. I think if you look at most languages, I don't think there's a language like Elixir, which for like such as a short time, it has managed to, to increase what it can, like to just make itself like a Swiss army. For instance, in Elixir, you can do web applications, you can do, I think currently there's live view native, which will allow us to be able to develop like native like applications for phones. There's something like Scenic, which can be used in IoT applications. We have NAVs. So the domain that you can use application Elixir is like across the board. You can also do it for almost anything that has a screen on it. And at times GIS is used, across different domains, not just the web. And for many who don't know, most of GIS is actually not on the web. It's actually in most of those, government departments, in form of maps and all that. But with the Elixir and its tooling, it allows us to, just be able to use it across all these areas, which I think the next phase of the graphical based application is where it's going on, especially with the onset of things such as IoT, something like machine learning, AI. So there's like a lot of things that Elixir can take you, and especially just supercharge your GIS application. So there's also the aspect of the community has worked on creating some packages, which allows us to better work with GIS applications. So if you remember earlier, I shared that the data types used by GIS is slightly different from what we are used to. So there's among the packages we have is Geo, then there's Geo Post GIS, then Topo, among others. So this one makes it easier for you to just start working with any GIS application or data. So most of these have been developed by the community, and they conform to the different standards that have been set. Yeah. So what would a typical tech stack for a GIS application look like? So we'll have something like a spatial database. I think presently most databases have tried to integrate the spatial aspect into them, in as much as most of us don't really know. But if you look at SQLite, MySQL, MariaDB, Postgre, all of them have some spatial aspect into them. So this one makes them spatial ready. So in as much as it requires some extra effort to just do it, but spatial database is key to this. So there's also the aspect of language and framework. So something like Elixir already has the different packages to allow you to work with the GIS application, something like Geo, GeoPost GIS, which I've shared earlier. And also a framework like NAVs can be used to develop distributed autonomous solutions. So especially with the onset of IoT, sometimes we need to know where a device is in the field. And this one can actually be made possible through a device pinging us its location, and we just put it in a map, or just collect some information from it and use that information to be displayed in a map. There's this site. So this is an example of an Elixir, an application that has been done using Elixir. It's GIS heavy. Yeah, so I think that's all for this. So maybe I'll try and show, I wanted to do like some demo, but I had an issue with my PostGIS installation, but I'll just take you through how you'd start working with making your application GIS ready. So let me stop sharing, share something else. So when working with, when you start to work with GIS, so there's this which is called, so this is a proprietary GIS application. So back in the day, if you look at most people actually used this. So this was before the onset of WebGIS. So we had ArcGIS, which was like among the biggest guys in the industry, but it's paid and it's really expensive. But there's also this which is called QGIS. I'm sure you've maybe seen it somewhere. So this one is used. So one thing you can do is, in my case, where I can like integrate this with an Elixir application. So what this will do is, let's say you have a situation that there's some people in the field are supposed to fill this data, or you just want to have like the base maps of a certain area. So for instance, in this case, we have like this one shows I think all the words in Nyanza province. Then you can come and see this one shows all the sub locations. So as I shared earlier, Elixir is, I mean, GIS consists of layers. So you can actually overlay all these together. Then you have this which shows the sub-counties. I think this shows like the entire region. Yeah. So if you go to this one, you'll see it has like more information about this data. Just remove this. Yeah, so this one has like more data, for instance, the ID, the name, among other things. So you can actually just use this as your basis and continue to add more fields on this table. So to do that, one thing I think I had done this, so you'd like create a DB, like connect to the database which has this data, and you connect your Elixir application to the same database. And to be able to use this, so for instance, I was using Postgre, so you have to make it to be location aware. So to do that, you create an extension called PostGIS. So once you do that, it will be able to see things such as points, polygons, among other things. So it won't just see it as a normal Postgre database, but it will see it as a spatial database. So if you also look at, let me show you. So for instance, if you come here, just get rid of this. So there's the libraries which I mentioned. So there's Geo, PostGIS, and Geo. So
we can
can
only
you hear
see,
me?
yeah, but we are seeing the Gmail screen.
Sorry, let me see if I can share this. Just a second. How about now?
Nice. Now we can see it.
Yeah, so there's a number of libraries which I mentioned, something like Geo. So for this one, you see it's like a collection of GIS functions, and those conversions to and fro, well-known test. So this one is like a GIS, it's something in the GIS domain. There's also well-known binary. So these are different ways of data representation. So through this library, we are able to interlink with that. So you see this one has like this type of, it has like a point Z, all this. And this is how you'd add it on your application. Though the documentation is not that great, I think I'll do like I'll do a PR to just help improve, especially when you're starting off. I think it's a little bit harder to know what to do. So there's also this PostGIS. So this one is the one that links our application to the GIS, to the PostGIS, and the PostGIS works with the Geo part. So for instance, you need to add the Geo and the Geo PostGIS. So I think for when you're using Ecto, you'll have to do like add this extra types. So since this is like a geographic, it's like a different type you're adding on Postgre. One good thing with Postgre is you can add extra types on the database. So that's what you're doing here. And if you look at our config, database config, we are calling it here. So this one, with this line, we'll make our application now GIS ready. And take note of this part. So I'm sure you haven't seen this type of data type, like we are used to strings, integers. Now geom is part of the GIS, so it's like something I think geometric. So we just tell it to use GeoPostGIS geometry. You can use GeoPostGIS point when you're doing a point, when you're doing a line string, such kind of stuff. Yeah, so this is just how you'd set up your application. So you see, for instance, this part, we are adding a geometric column called on test. So this one is latitude and longitude. In this case, it will be a point. So something like I want to know location of a hospital and stuff like that. Yeah, so that's what you do there. Then you use topo. Topo is just a way to like make sense of these GIS applications. So for instance, you'd want to find like the number of methods you have. You want to find whether, let's say there's a disease that has started to, we have like a case of an outbreak of a disease. We want to find if this disease is within a certain area, if there's an intersection between the different polygons or even the points that we have. There's this part within. So this one allows you to just do more calculation on your data. And yeah, you can use, Elixir is well equipped with some of the tools, especially when you want to do this on the fly. And at times you need to just make these decisions really quick. So with tools such as this, you're able to facilitate that. Yeah, I think yeah, you can take a look at this. Like these are like the main things you need to get started with working with the GIS applications, and maybe just look at QGIS among other things. And as I shared earlier, if you're a software engineer, you're actually 50% a GIS developer. So you just need to learn a few things, such as this, go through PostGIS documentation, among other things, and you'll be good to go. Yeah, I think that's all for my presentation. I'll welcome any question, concerns.
Nice. Thank you so much. Oh. Anyone with question? Yeah, Elliot has just posted one. Are you capable of scraping coordinates from a website so you can extract the coordinate information of the geometric features?
Yeah, so this one depends. One thing with if you look at maps, so I think there's actually there's a solution which is really there's a solution called rewards. So that one, what it does is, for instance, in Africa, there's the issue with addressing. Let's say, I think if you look at the developed world, almost every place has an address. So let's say you send a package, it will actually arrive to that place. But in Africa, it's really tricky to, like, if you say you stay in this place, I'll have to just call you to come and pick me, among other things. But there's a solution called what rewards. So what it did was it took the world and divided it into 3 by 3 meter square areas. So you can actually address that. And each of these areas has like an address to it. If you look it in a map, it will take you to that particular place. So you're able to like do that. And now scraping the coordinates from the website is not that, because as I mentioned earlier, there's something called georeferencing. So for instance, you'll have an image, it needs to be like georeferenced to show the coordinates, among other things. So in as much as you can fetch something like, I think the coordinates of an IP, which is used once in a while. Yeah, but getting it from a map is hard, unless if you look at something like Google Maps, you're able to do that. Because if you look at Google Maps, the way you are panning out, it shows you the different coordinates. That's because that particular map has been georeferenced. Without that, you can't really get those coordinates. And also, now when you're getting the coordinates, maybe I can share, let me just share something. So there's that site which I shared earlier. Let me see. So there's this. So this felt, I think, is written in Elixir. So if you look at, so this allows you to create maps together. So because it's like one thing I know is they have a map. They have this. So through so this all that information in a multi-polygon, and when you save it in your, so that's how I'm assuming it's working. So when you save it, it just saves it at as a multi-polygon. The same case with if you do a point. Look at this. That means that this is georeference, so it has each and every area has like a coordinate to it. When you draw this, we are collecting that coordinate. Yeah. I don't know if that's your question.
Ali, did that answer the question? So it means like even when you're scrapping, you have to be scrapping either the polygons or the coordinates, points, the lines.
Yeah. So yeah, you have to do that. So for instance, I think there's some time back I had an idea where I wanted to determine, like, let's say, if you want to know the forest cover of a country, using AI, like machine learning and all that. So I wanted to like create a script which just goes to Google Map and start like scrolling the area, taking pictures, just determining the size and all that. So the issue with that is when you like screenshots, you'll find that it's an image. So you want to know exactly what this area is. So one thing you'd need to do is just take all the screenshots with the forest and all that, and bring it to a GIS application. So you have to like georeference that particular, all those screenshots to be able to determine that, oh, this is a forest and this one is not. So once you determine all the areas that are forest, you're able to compute the size of that and determine the amount of forest cover in a country. Yeah, so you can use it. So you can actually do that, but you'll have to further process that particular data to get better insights. Yeah.
All right. Thank you. I hope that answers your question, Ellie. Anyone else with a question? Right. I think people really got the point. So thank you so much, Paul. To those of us who thought the earth is flat, I think we're doomed. Yeah, but that was so insightful. I think maybe I'll also start looking into the GIS. So you say that the hardest part is cleaning the data.
Yeah, I think GIS, your data is like your everything. So the collecting of the data, that is like where most of the work is, and just cleaning it. Yeah, and one thing I can advise people in this call, actually GIS application developer is a role out there. Even if you just check out GIS application developer, you'll actually see there are a lot of roles doing that. So it's an area you can venture into. Considering like not all of us should be web developers, so it's something that you can try and look into.
Okay, so you have more questions streaming in. So Ellie's
So
requesting
I
if you
think
can
maybe
chat later. I don't know if you can share your contacts or how can they reach you?
yeah, so they
So that
can reach me on Twitter. I think I have my Twitter handle where I can provide all this. So for instance, there's that like the administrative data. So there's a site I think called GADM. I believe it's gadm.com. Let me just, so it normally has the location data of the world. But maybe I'll confirm later and just I can share it with people who want to get that particular information. Yeah, let me just, so it's GAD, let me share it on the chat. So if you want to start with any GIS application, you need, you'll need these base maps. So for instance, there in that site, you can download the map of Kenya, different counties and all that, and there are like tons of data. And if you just look through the web, you'll find different, so there's like different types of data out there. And you can actually create your own data if you want. And also there's OpenStreetMaps. They normally have like a lot of data. I think, for instance, the data of Kenya was at some point it was about 30 GB, which was showing like a lot of things in Kenya, maybe point of interest, health centers, and all that. So it's just, as I mentioned earlier, they have the data. If you do that, it is all good there.
Nice. So I've also linked his Twitter profile on the chat, so feel free to DM him. All right. So thank you guys for coming in. We are going to post this on YouTube so that those who missed can have a chance to watch. We're also going to share a feedback form, so kindly fill it in. Tell us what we did wrong or what we can improve on for next time. Asante sana, Paul, once again. So we have this webinars on the last Friday of every month. We will share with you guys the speaker for next month. So let me stop sharing.